Hello students. So we will going to start a topic lateral displacement. Lateral displacement आपके क्लास 10th का लाइट का एक पोर्शन है चैप्टर नंबर 4. So I'm just explaining you how to draw that and what the understanding we will create by this. Okay. So first we need to make this thick glass. So let me take one shape which is actually showing you clear understanding regarding of this glass. Okay, so this one is your this glass. So for example like this, so I am taking this and shaping them according to the size of this diagram. So as you know initially that when we are going to discuss about reflection or refraction phenomena, so for example this one is your one ray. From that ray you are making one normal. That normal should be a dotted line, so it will create not a confusion and clearly representing your diagram. Now another one ray is going to be incident here, point of incidence, and because it is an incident ray it is coming from this medium to this medium. But what is the meaning of this medium to this medium? So it's a medium 1 and it's a medium 2. So medium 1 is your rarer medium, rare medium, and second one medium in which that incident ray enters, that is considered as your denser medium. Okay, so to give you a little understanding, this one is your denser medium. Denser medium may be a water, maybe a glass, maybe a diamond, maybe a oils, etc. Okay, it may be. Now when your incident ray enters in that particular denser medium, so it will bend towards a normal, and that I already explained you in my previous lecture that whenever your rays enter into a denser medium and which having a more refractive index, so they will bend towards a normal because of lowering in their speed of light, and because of a formula of a speed is equals to distance upon time. Because the speed is going to be lower, so it's a directly proportional to your distance, so it is also lower. So it is a kind of a phenomena, that's why they are bent towards your normal. Now the next one is your when your rays enter into it and they are going to inside of that medium, so some part is also reflect here, but this is only a 4%. 96% strength are going to be a downside. Don't clutter your diagram so much. Try to make a concept in your mind. Try to keep things in your mind. Okay, so this one is your what? Normal, and this is your angle I. Angle I is your angle of incidence, and this is your what? R. But basically if you see, this one is your actual path of your ray. So because it's a just assuming that, so I am making with the dotted line. So this one is your what? Deviation path, and deviation path we are representing by the delta. So this is your complete phenomena by which your one incident ray enters into a from one medium to another medium, and that we call a refracted ray. Okay, and the phenomena is known as by what? Refraction, and that is your what? Reflected ray. Okay, now we are coming on our point, lateral displacement. So here I am using again these basic things. First I am making that normal. Okay, and after that incident a one line on this point, because as I explained you already, when any ray enters from rarer medium to denser medium, it bends towards to the normal, so it will bend like that, and again it is making a normal with the with that particular end of your glass. So this is your normal again. Now because in this situation, because it is a glass, So it is a denser medium, and this is your air, this is your rarer medium, this is your air again. So it's a rarer medium again. So when your rays enters or move from denser medium to rarer medium, they will move away from the normal, like this. Okay, like this. So this is your way, or this is your path of your rays. Now I need to make some angles. So this one is your I, this one is your R, and this one is your again R, because internals and opposite angles are same in that area. And this is your another angle. Now I'm giving you the name of that. So this one is your incident ray, okay, and this one is your what, this one is your what, refracted ray, and this one is your finally emerge out. So it's a emergent ray, and that particular angle is your angle E. So here I am writing angle I is your angle of incidence, angle R is your angle of refraction, angle E is your angle of emergence. Okay, now this is a time to understand what is the meaning of a lateral displacement. So here I am using a different color. So as you see, this is your ray, and you can see that this is a ray, a kind of a structure like this. So that means this one is your actual path. Okay, so because it is a assuming situation, so I need to make it by some dotted lines. And this one is your what, distance from emergent ray as well as with your actual path of your ray. Okay, so this one is your what, distance, and that distance is your 90-degree angle. That means that particular distance you call it a lateral displacement, and we can write a sort of definition of lateral displacement here. What it is? It is the perpendicular distance between emergent ray and the direction of incident ray. So hopefully you understand what the situation it is going on. Now the next one, and very important, and I need to finish it in the same understanding. So first one is your what, this and this is your what, both are alternate angles. Okay, that means those are the interior one, and that's why they are the same, because these information you need to use to solve the numericals on the basis of a lateral displacement. Okay, so hopefully you understand what is a lateral displacement. This one is your incident ray. When it is fall on a particular point on a glass, on a thick glass, so it will normally bend towards to the normal, and it not normally bend, it is move bend towards to the normal, and when it hits on the another line of this glass, it will move away from the normal after refraction, because it is enter into a denser medium to a rarer medium. and as you see in that ray difference, you will get a distance from the actual ray path and from the emergent ray. So that is known as your lateral displacement, and we can say that now it is the perpendicular distance between the emergent ray and the direction of incident ray. Okay, so two observation you can easily see here. So what the observation you can get from lateral displacement? First one, emergent ray is parallel or not? It's a parallel. It's a parallel to the direction of the incident ray. Okay. Next one, angle I is equals to angle E. That particular angle I and that particular angle E, at the angle level both are the same. So this is your very important observation. मैं इसको एक बार बहुत सिंपल लैंग्वेज में और समझा देती हूँ. ये लेटरल डिस्प्लेसमेंट आपको ये बताता है कि जब भी आप किसी डेंसर मीडियम से, फॉर एग्जांपल ग्लास से रे को पास करते हैं, तो जब ग्लास से पास होने के बाद फाइनल रिफ्रैक्शन आपको मिलता है, उसका डिस्टेंस आपकी एक्चुअल रे से होता है. दैट डिस्टेंस इज नोन एज योर लेटरल डिस्प्लेसमेंट, बिकॉज दैट displacement occurs laterally. That's why we are using the word of a lateral displacement. And उसके बाद जब आपका lateral displacement आपको दिखता है तो उसका नेचर कैसा होता है? It is a parallel with your emergent ray. That is an important one. And after that जो angles बने हैं, angle I and angle E, दोनों बराबर होते हैं. That means angle of incidence, angle of emergence are same. Okay. So this is a story of lateral displacement, and that continue with the another thing. Those are the depending factors that we will going into the next lecture of lateral displacement. Thank you so much.